Good morning, friends. After the discussion of the what is the kinetic theory of gases and also what is the usage of the kinetic theory of gases. Now some basic definition. What is the mole? What is the Avogadro number? What is the modern definition of Avogadro number? What is the universal gas constant and its value? And in which condition the gases are known as the ideal gas? And what is the equation of state for the ideal gas? We are going to discuss this thing. First thing, what is mole, and write its two different equations. Already in equation of state, that means the equation showing the relation between the pressure, volume and temperature. So according to the Boyle's law, at constant temperature, PV upon T is given constant. That means the PV is equal to constant for given temperature constant and given quantity of a gas. Therefore, PV is equal to mu RT. Mu is the quantity of a gas and R is the universal gas constant. So this equation PV is equal to mu RT, that is known as the equation of state. PV is equal to mu RT. That is known as the equation of state. Now, here we are going to define the first what is the mole. At standard temperature and pressure, that means at STP, the mass contained in 22.4 liter volume of gas is equal to its molecular mass. And this quantity is known as 1 mole. Again, at standard temperature and pressure, that means at STP, the mass contained in 22 liter of gas is equal to its molecular mass. And this quantity is known as the 1 mole. That is known as the mole. At given temperature, that means at standard temperature and pressure, the mass contained in 22 liter volume of gas is equal to the molecular mass. And quantity of gas is called the 1 mole. So whatever the quantity in a gas in 22 liter of volume of a gas at STP, that means the standard temperature and pressure, this quantity of gas is known as the 1 mole. Again, the quantity of a gas in 22 liter volume of gas at STP, that means the standard temperature and pressure, is known as the 1 mole. And the mass of this 1 mole is known as the molecular mass. That is known as molecular mass. Again, the definition of 1 mole gas. The quantity of a gas in 22 liter volume of a gas at STP, that means the standard temperature and pressure, such quantity is known as the 1 mole. And the mass of this quantity is known as the molecular mass. Therefore, the definition is in that form. At standard temperature and pressure, mass contained in 22.4 liter volume of gas is called the molecular mass, and the quantity is known as the 1 mole. Its symbol is MOL. Symbol is MOL. To represent the quantity in mole, we can add the symbol MOL. Molecular mass of 1 mole of gas is M0 and M be the mass of given gas, given quantity of a gas. So which contain the mu mole gas. Therefore, M is equal to mu times M0. M0 is the mass of 1 mole gas. In a given quantity of a gas, there are the mu mole gas. Therefore, the total mass of a given gas, M is equal to quantity into mass of 1 mole. Therefore, M is equal to mu M0. Therefore, quantity of a gas, mu is equal to M upon M0. Again, the molecular mass of 1 mole of gas is M0. And M be the mass of gas which contain the mu mole gas. What is the M? M is the total mass of a given gas. In given gas, there are the mu mole of gas. And mass of the 1 mole gas is m0. Therefore, total mass M is equal to mu into m0. Therefore, mu is equal to m upon m0. So that gives the quantity of a gas in mole. Mu is equal to m upon m0. Now we can also mention the quantity in mole from the number of molecules. Now we know that in 1 mole gas there are Na number of molecules. Na, that is the Avogadro number. The number of molecules in 1 mole of gas, that is known as the Avogadro number. Again, the number of molecules in 1 mole of gas is known as the Avogadro number. Therefore, in 1 mole gas, there are Na. That means the number of molecules is equal to Avogadro number. In given mu mole, there are capital N number of molecules, then N is equal to mu into N. What is the N? Capital N. N is the number of molecules in given quantity of a gas. Na, Avogadro number, is the number of molecules in 1 mole of gas. Therefore, total number of molecules is equal to quantity into number of molecules in 1 mole. Therefore, N is equal to mu into Na. Therefore, mu is equal to N upon Na. Mu is equal to N upon Na. So these are the two different equations of mole for the quantity of a gas in terms of the mass and in terms of the number of molecules. So this equation frequently we are using in numerical and also in equation of state. Again, what is the definition of mole? At standard temperature and pressure, mass contained in 22 liter volume of gas is equal to the molecular mass and quantity is known as the 1 mole. Again, at standard temperature and pressure, that means at STP, the mass contained in 22.4 liter volume of a gas is known as the molecular mass and quantity is known as the 1 mole. Whatever the quantity in 22.4 liter volume of the gas at STP is known as 1 mole. Now, symbol of mole is only MOL. The molecular number of 1 mole of gas is MO and M be the mass of a gas which contains the mu mole gas. Therefore, total mass of the gas M is equal to quantity into mass of 1 mole. M is equal to mu M0. Therefore, mu is equal to M upon M0. So that is the quantity of gas in mole in terms of the mass, ratio of the total mass to the mass of 1 mole gas. That gives the quantity of the gas in given container. Now the same equation in terms of the number of molecules. In 1 mole gas, there are Na, number of molecules. Na is the Avogadro number. What is the Avogadro number? The number of molecules in 1 mole of gas, that is known as the Avogadro number. Again, the number of molecules in 1 mole gas is known as the Avogadro number. In given mu mole, there are n number of molecules, capital N number of molecules. Therefore, N is equal to mu into N. Again, in 1 mole gas, there are n number of molecules. Now, in given mu mole quantity of a gas, if there are n number of molecules, therefore n number of molecules is equal to mu into N. Therefore, mu is equal to N upon Na. So these are the two different equations of the quantity in mole in terms of the mass, in terms of number of molecules. Now, after that, what is the Avogadro number and that its value? The definition of the Avogadro number is that the number of molecules contained in 1 mole of gas is called the Avogadro number. It is denoted by Na, N suffix A, not Na. Again, the definition of Avogadro number. The number of molecules contained in 1 mole gas is called Avogadro number. It is denoted by Na. Its value is 6.02 into 10⁻23 molecule per mole. Again, we repeat the definition of Avogadro number. The number of molecules contained in 1 mole of gas is called Avogadro number. It is denoted by N suffix A. And A is equal to its value 6.02 into 10⁻23 molecule per mole. Clear it? Okay. Now the modern definition of Avogadro number. What is the modern definition? The number of atoms in 12 gram carbon. The number of molecules or the number of atoms in 12 gram carbon is called the Avogadro number. The modern definition of Avogadro number is this. While old definition is the number of molecules in 1 mole of gas is known as the Avogadro number. Here, the number of atoms in 12 gram carbon is called the Avogadro number. Again, the number of atoms in 12 gram carbon is called Avogadro number. Avogadro number can be used for every type of fundamental particles. Avogadro number can be used for every type of fundamental particles, like as the atom, ion and electron. 1 mole atom is equal to 6.02 into 10⁻23 atom per mole. 1 mole ion is equal to 6.02 into 10⁻23 ion per mole. 1 mole electron is equal to 6.02 into 10⁻23 electron per mole. So, according to the modern definition, we can apply the Avogadro number for each and every fundamental particle, like as the atom, ion, and also the electrons. Okay. Now, after that, by using the ideal case equation, PV is equal to mu RT, that the value of constant R, unit, and its dimension. Again, by using the ideal gas equation, PV is equal to mu RT, there is the equation of state. That value and unit and dimensional formula of R. So PV is equal to mu RT, P is the pressure, V is the volume, T is temperature, mu is the quantity of a gas, and R is the constant. I is known as the universal gas constant. So ideal gas equation, PV is equal to mu RT. So from this equation, I is equal to PV upon mu T. I is equal to PV upon mu T. P is the pressure, V is the volume, mu is quantity of a gas, and T is the temperature. Here the R is universal gas constant. At standard temperature and pressure, temperature is 273 Kelvin, pressure is 1.01 into 10⁵ Newton per meter square, volume is 22.4 liter, that means the 22.4 into 10⁻³ meter cube. So keep in mind here the relation, 1 liter is equal to 10⁻³ meter cube, minus meter cube. That is the relation between the liter and meter. That is important for the numerical. Because the volume is given in liter, we require to convert this liter into meter. Again in STP, temperature is 273 Kelvin, pressure is 1.01 into 10 is to 5 Newton per meter square, and volume is 22.4 liter. That means the 22.4 into 10 is to minus 3 per meter cube. And mu is equal to quantity of a gas is 1 mole. So substitute in this equation, I is equal to pressure 1.01 into 10 is to 5 into volume V, 22.4 into 10 is to minus 3 upon mu 1, temperature 273. As we simplified, we obtain 8.314 joule per mole into Kelvin. Joule per mole into Kelvin. Now, dimensional formula. Mu is the unitless quantity, therefore joule per Kelvin. There is the same dimension of Boltzmann constant. Same dimension of Boltzmann's constant. Therefore, dimensional formula of R is M1 L2 T minus 2 K minus 1. That means the joule per Kelvin. Again, the dimensional formula of R is M1 L2 T minus 2 K minus 1. Also, R is equal to Na into Kb. That means the Boltzmann's constant into Avogadro number. So it also 8.31 joule per mole into Kelvin, and that is known as the universal gas constant. 8.314. That is the value of universal gas constant R. Now, next is what is the ideal gas? What is the ideal gas? In which condition the gas we can consider as an ideal? Ideal gas is not real. That means in reality, no any gas is ideal, but we consider in particular condition the gas is an ideal gas. A gas satisfies the equation PV is equal to mu RT, and every pressure, that means the low pressure and high temperature, is called an ideal gas. The gas satisfies the equation PV is equal to mu RT at every pressure, that means the every low pressure and high temperature. Such gas is known as an ideal gas. That means any gas at low pressure and high temperature, if there is satisfied this relation PV is equal to mu RT, we can consider this gas as an ideal gas. At low pressure and high temperature, the molecules are far apart and the molecular interactions are negligible. Hence, in this case, the gas behaves like an ideal gas. While at low pressure and high temperature, all gases behave as an ideal gas. At low pressure and high temperature, molecules are far apart. That means the distance or the separation between the molecule is very large. So in this case, the molecular forces of the interaction, atomic interaction or the molecular interaction are very, very small, that can be negligible. So in this condition only, the gases behave like an ideal gas. Right? Equation of state for the ideal gas is PV is equal to mu RT. For T constant, PV is equal to constant. At given temperature, the product of the pressure and volume of an ideal gas is remain constant. Again, what is the definition of an ideal gas? A gas satisfies the equation PV is equal to mu RT. At low pressure and high temperature is called an ideal gas. Why at low pressure and high temperature the gas is known as the ideal gas? Because at low pressure and high temperature, the molecules of the gases are far separated, but the separation between the molecules is very large. Therefore, intermolecular forces or the interatomic forces are negligible. In this condition, the gas behave like an ideal gas. Again, at low pressure and high temperature, the separation between the molecule is very large. So in this condition, the intermolecular interaction or the intermolecular forces is negligible. In this condition, the gas behave as an ideal gas. The equation of state for an ideal gas is PV is equal to mu RT. For given temperature, it means for constant temperature T, PV is also constant. Clear this? Okay, so there is the definition of mole Avogadro number, modern definition of Avogadro number. After that, what is the universal gas constant and what is the ideal gas or in which condition the gas behaves as an ideal. Clear it? Okay. After that, we will start our discussion about Boyle's law or the laws of gases.